Hello students, we are going to discuss about atmospheric diffusion theory. First of all, we are going to discuss dilution effect of wind velocity. Smoke which is discharged into the atmosphere, advection by the wind and diffusion by the wind turbulence work to dilute it. What is advection? Advection is nothing but transfer of heat or matter by the flow of a fluid, especially horizontally in the atmosphere. Example, transport of pollutants in a river by bulk water. So dilution by the advection of the wind is directly proportional to the wind velocity. So figure illustrates the dilution by the wind. So dot in the figure represent smoke as separate masses. Generally this is called puff. This circle is called puff. So when the wind velocity is 1 meter per second, what is the meaning? The distance becomes 1 meter and at a velocity of 2 meter per second it becomes 2 meter. So the distance between puff shows the dilution effect. What is puff here? This circle is called puff. So the concentration is inversely proportional to the velocity. Next one, atmospheric boundary layer. The wind blows around, over or through trees, forest, mountain and a cluster of high-rise buildings in cities. Irregularity of this ground surface is called roughness. So the roughness disturbs airflow and produces eddies and turbulence shown in figure. In the turbulent airflow, wind velocity and wind direction changes with respect to time. What is turbulent flow? The flow where the direction of the wind and its velocity change randomly is called turbulent flow. The wind in the atmosphere is the most typical turbulent flow. The turbulence of the wind created by the roughness of the ground is the strongest near the ground surface and decreases as it rises in the sky. What is atmospheric boundary layer? The atmospheric layer where the airflow is influenced by the ground surface. This is called atmospheric boundary layer. What about the wind velocity? Wind velocity and turbulence changes with respect to altitude. Altitude means height in the atmospheric boundary layer. So our wind velocity is weak near the ground surface due to drag force of the ground, but it increases at a higher altitude. Are you clear? So here wind blows around, over or through trees, forest, mountain and a cluster of high-rise building in cities. Here forest, city, suburb, plant. So these are the wind velocity distribution profile. So here in city turbulence is strong. Why? Because so this is the no gap between the buildings. The gap is less. So due to turbulence is high. So due to this reason turbulence is high or strong in a city. No gap. The gap is less. So here suburb, turbulence is medium. Why? Because So having some distance between the buildings. Due to this reason, turbulence is medium in suburb, whereas plain turbulence is weak, the more space. So turbulence is nothing but zigzag or circular movement of air in the atmosphere. Okay. Next one, concept of the atmospheric boundary layer with the mixing layer, the neutral boundary layer and the ground inversion layer is shown in figure. Difference in temperature exists at ground level, such as the temperature of the surface of the water and the ground in addition to the roughness. Roughness is nothing but irregularity of the surfaces. Convection occurs because solar radiation can warm the ground surface during the daytime in fine weather, and the temperature of the air near the ground level rises. So this convection motion is one of the biggest causes of turbulence in the wind. So next one, mixing layer. What is mixing layer? Atmospheric boundary layer where the convection is active in the daytime. This is called mixing layer. So another one is the neutral boundary layer. What is neutral boundary layer? Convection is weak when it is cloudy, but the atmospheric boundary layer where the effect on wind velocity is dominant, that is called neutral boundary layer. On a night of fine weather, heat escapes from the ground surface into the sky through what? Infrared radiation. Temperature of the ground surface falls and the air near the ground is also cool or chilled. Vertical temperature of the atmosphere falls rapidly near the ground level. This layer is called inversion layer or ground inversion layer. So the turbulence of the wind decreases in the inversion layer. Are you clear? So here this is night time due to infrared radiation, the stable layer 200 meter. This is cool or chill. Are you clear? This is the chill. So on a night of fine weather, heat escapes from the ground surface into the sky through infrared radiation. So the temperature of the ground surface falls and the air near the ground is also chilled or cooled. Are you clear? Last one, the relationship between the vertical profile and the thermal stability of the atmosphere. So this graph drawn between temperature and distance. Temperature decreases upward in the atmosphere. Temperature lapse rate is 0.98 degrees Celsius for every 100 meters. When the atmosphere is of dry air and the movement of the air mass is supposed to be adiabatic. What is adiabatic? There is no heat loss or gain. It is called dry adiabatic lapse rate. So the symbol of dry adiabatic lapse rate, gamma D. When lapse rate is greater than gamma D, this is unstable condition. When lapse rate is less than gamma D is nothing but adiabatic lapse rate. This is stable. When lapse rate is equal to gamma D or adiabatic lapse rate, this is neutral. Thank you for your attention.